Hello, students. Good evening. How are you? Hope you are good and enjoying the time. So good to see you. I'm here with you with the question discussion on simple harmonic motion that we have covered recently. So I think this would be the wise decision that is made by me that we will discuss the same chapter question that we have just finished. Okay. So this question discussion session will be more collaborative because we have just finished this chapter. So the concepts are fresh and new to you, and you don't need to that much of revision. Ki, oh, what was that chapter and all. So let me just get started with it. Firstly, what we are going to do, we will revise the concept, some concept that we are going to that we need today. We are going to do that, and then we will see the questions of various types finally. Okay. So to learn, we have to earn, and now move this. Okay. Just a second. Yeah. So firstly, what we will going to do, we will do the some concept revision of SHM. Now, what is SHM? Firstly, let me just name it SHM. So SHM is nothing but the simple harmonic motion. Okay, just give me a moment. Okay, so sorry for the disturbance. Now, let's just continue with this simple harmonic motion. So it will be simple harmonic motion. Okay, this is the full form of SHM. Now, what is a simple harmonic motion? Simple harmonic motion is a kind of oscillatory motion. Oscillatory motion, and oscillatory motion means the motion which is to and fro, or you can say back and forth. Okay, so this kind of motion is termed as oscillatory motion, which is to and fro, back and forth about a mean position. Mean position. Got it? Now this, the simplest form of SHM, simplest form of oscillation, simplest form of oscillatory motion is SHM, which is given by, if you talk about the force equation of oscillatory motion, it is F is equals to minus, or you can say K into minus X raised to the power N. Okay, where N is the odd integers 1, 3, 5. So the very simple case that is possible here is N is equals to 1. So when N is equals to 1, when N is equals to 1, this force will become minus of Ax. So if a motion is executing under such a force, F is equals to minus Kx, that motion is termed as SHM. This force is of restoring type of force, restoring force, which means it is a conservative type of force also, which restore its value after being displaced. Okay. So this is the restoring, like our gravity is a restoring force. The spring force is the restoring force. When you extend it, then to compress it back again, you do not need to do any work. The work that is done by this restoring force is stored in the form of energy, and another work is done by on the expensive of that stored energy. So this is the concept of restoring force. Okay, now the motion equation of SHM is given by d2x by dt square is equals to minus k by m into x. So this is the second order differential equation. How it has been come, I have already discussed it in the regular classes. The solution of this equation is termed as a sine omega t plus phi or delta, or x is equals to a cos omega t plus phi. Okay, so these are the equations. These are the solution of this equation. D2x by dt square equals to minus k by m into x. Okay, where omega is the square root of k by m, and which is angular frequency, okay, of the particle. Now, so there are two types of equation that we have deal in this. First is the time equation of SHM, and second is the displacement equation. Displacement equation of SHM. Now in displacement SHM, the variable will depends on the displacement of the particle. Obviously, first thing to note here that all the measurements in SHM are done from mean position. Mean position. So we always measure the distance, or measure the energy, or you want to measure the velocity. So we always measure these parameters from origin, or origin in SHM is mean position of that. Okay. So the time equation, there are x is equals to the recently that I have discussed, a sine omega t plus phi. If you differentiate this one, you got the velocity, which is a omega minus a omega, sorry, a omega cos omega t plus phi. If you again differentiate this one, you got acceleration, which is minus a omega square sine omega t plus phi. Now, one thing also you can note it down, that what is the condition for a motion to be SHM? The condition for SHM is equals to that the acceleration of the particle which is executing that motion directly proportional to negative of displacement, or should be in the form of minus omega square x. So if these two conditions are verified, that motion is simple harmonic motion. Simple. Now, if I talk about the displacement equation, let me change the color here. Okay. So displacement equation, we have seen that force is equals to minus kx in SHM. Okay. If you want, if you apply the Newton's law here, this force will become F is equals to ma. So acceleration will become minus k by m into x. Okay. Now, if you differentiate or if you take the dv by dt and calculate the velocity will come out to be this one. Just a second. This one. Just give me a second. Okay. So displacement equation, we have three equation here. In time equation, we have three equation there. Now these equation you can double it. If you take x is equals to a cos omega t plus 5, then you differentiate it and get velocity, and then differentiate it, you will get the acceleration. So this sine cos will change there. So these extra three equation you will also have. So total six equation you have in the time equation, and these three equation in the displacement will remain same. Okay. So these are the equation. Although you can write it as v square is equals to omega square a square minus x square. So this you can also note it down. Okay. So these are the important one. Time equation and displacement equation. Got it? Now, how to choose that which one we have to take? Either we have to take the time equation f x is equals to a sine omega t plus 5, or we should choose x is equals to a cos omega t plus 5. So it totally depends on you if you are executing a SHM. Okay. And also it is also given in the question. Based on that, you need to take it. So if a particle is at x is equals to 0, and I will consider it as mean position. Okay. These are the extreme position, let's say plus a and minus a. Plus a and minus a are the amplitude of the SHM also. What is amplitude? Let me write the equation first here. X is equals to a sine omega t plus 5, or I will say phi naught. Okay. Now here a is the amplitude. And what is amplitude? Amplitude is the maximum positive displacement from mean position. Okay. So from mean position, the maximum extent that a body can go is termed as the amplitude of that particle or of that SHM from mean position. Got it? Now this omega t plus phi naught, you can consider it to be phi totally. This is nothing but the phase of SHM. And what is phase? Phase tells us about the status of the particle. Status of the particle executing or is in SHM. So the particle which is in SHM, this omega t plus phi naught will tell you about the status of that particle. What is phi naught? Phi naught is the phase constant. Phase constant. And it tells you about the initial conditions. Initial condition. Or you can say at t is equals to 0. So at t is equals to 0, where the particle is, okay, that is told by us, told by this phi naught, which is the phase constant here. Okay. Now, if you take this equation and take phi naught is 0, which means phi naught is 0 also, because it is at x is equals to 0, at t is equals to 0, this particle or this block is executing SHM and moving towards the positive direction. Okay. So x is equals to 0, a sine omega t plus phi naught. At t is equals to 0 also, so this will also become 0. So this sine phi naught will also remain, will only the remaining thing inside it. And this a is not 0, a is a constant, positive constant. So this sine phi naught will be 0. So sine phi naught, which means phi naught has a value of 0 degree. Okay, because sine 0 is 0. So see, it is telling us about the initial status of the particle. Okay. So here, if you talk about this one, if you take cos x is equals to 0, x is equals to a cos omega t plus phi naught you are taking. And at t is equals to 0, let's say particle starting its motion from mean position. So put it x is equals to 0. So a here would be a cos omega t will become 0. Omega t will become 0 plus phi naught only. Now cos phi naught equals to what? 0 degree. So phi naught will be pi by 2, which means the initial phase or initial phase of the particle is at pi by 2. Got it? Now, so this is all about whether you have to take cos or sine. It is also given in the question. It's all the matter of phase difference. If you will see that it is showing 0 at 0 degree, but it is showing 0, this equation is showing 0 at pi by 2 degree, okay, or 90 degree, which means the particle has traveled something, because this phase constant to be 0, which means it has covered pi by 2 already. Okay, so that is why we have written it like this. Now, this is the first question on your screen. They categorize the following function of time, and the function is given you as sine omega t plus cos omega t, and you have to categorize in the category of SHM or periodic motion. And you had to tell us that it is periodic or not, or it is SHM or not. So let us consider it to be y is equals to sine omega t plus cos omega t. Now this is not completely in sine and not completely in cos, but the equation that we know for SHM is a sine omega t plus phi naught, or x is equals to a cos omega t plus phi naught, which means we need to convert it into these types of equations either completely in sine or completely in cos. Then we will decide that this function is executing SHM or not. Okay. And the another way to check it out that it is SHM or not, you need to differentiate it twice. Let me show you. I have already discussed the condition for SHM. And what is the condition for SHM? Condition for SHM is that d2x or d2y, if here we have assumed it y, or you can take it x, x is equals to this one, d2x by dt square is equals to minus k by m into x, or acceleration is directly proportional to negative of x. Let's see it is happen in this case or not. If I differentiate this, it will become dx by dt sin omega t. Differentiation of sin omega t will become cos omega t, and this cos omega t will become minus sin omega t. Again, if you differentiate it, d2x by dt square, it will become minus sin omega t minus cos omega t. This d2x by dt square is nothing but the acceleration. If you take minus common, then it will become sin omega t plus cos omega t. Now, minus sin omega t plus cos omega t. Oh, we have seen it. This is equation number 1. This is x. So it is minus x. So we can say that acceleration is directly proportional to minus x here. So we can say that this function is executing SHM. This function is executing SHM. Got it? Because here the condition is satisfied for SHM. Acceleration is directly proportional to minus x. So we can say that this function is executing SHM. Now, if I want to categorize it like this, x is equals to a cos omega t or a sin omega t plus 5. So how to find that one? So we have ways for do that also. The function that we have is x is equals to a sin omega t, sin omega t plus cos omega t. We need to convert it into either in sine or in cos. So what we are going to do, we make the conversion. There are two methods. Either you can apply this one, sin omega t. You can make this cos omega t as sin pi by 2 minus omega t. This one. Got it? Because sin pi by 2 minus omega t, which is in first quadrant, but here in the front we have 90 degrees, so it will convert it into cos. So cos omega t you will get in the response. Got it? So if you apply sin c plus sin d here, this you can consider as sin c, and this you can consider as sin d. And then you can apply the formula of sin c plus sin d, which is 2 sin c plus d by 2 into cos c minus d by. Got it? The second way to do that is, which is, I think, if you do not remember the trigonometric formula, this is far more simple for you. And what is that? You will write the coefficient which is written in front of sign. You can write it like this. If nothing is written, 1 is written here. So 1 sin omega t plus 1 into cos omega t. You will take these one square them and add them, and then take the square root. So it will become root 2. Now divide this whole expression in the right hand side by root 2 and multiply also by root 2. So when you multiply it and divide, the divide part we will take inside. So it will become 1 by root 2 sine omega t plus 1 by root 2 cos omega t. This will also convert it into a formula, which is you can write 1 by root 2 as cos pi by 4. So it will become sine omega t cos pi by 4 plus cos omega t. 1 by root 2 you can write as sine pi by 4. Okay. This is nothing but sine A cos B plus cos A sine B. Now sine A cos B, sine A cos B plus cos A sine B equals to sine A plus B. Simple. So you can convert it into like root 2 into sine A plus B, which is omega t plus pi by 4. Okay. Now this you can say can match your profile with x is equals to a sine omega t plus phi naught. If you compare with this equation, you will get the amplitude, you get the phi naught also. So this equation itself representing the SHM. So this is how you can find out the time period also and the amplitude of this system. Okay. Now move on to the next one. This. Now if a particle is in SHM and which is given by equation x is equals to a sine omega t plus b cos omega t, then find out the amplitude of the particle. In the same way you are going to do that, but the more predicted way to do this is take the coefficient, square them, then take the add them, and then take the square root of them, and finally multiply and divide it by that final thing that you have. Okay. So let's just solve it. Now you have x is equals to a sine omega t plus capital B cos omega t. Now I have already told you how to do this. You will do that by taking square root. You will just square it, a square plus b square. Now take the square root of that. It will become root a square plus b square. And finally, what you can do, x is equals to, you can multiply it with square root of a square plus b square. Okay. Divide by root a square plus b square. A sine omega t b cos omega t. Okay. If you multiply with this equation with this, x is equals to root a square plus b square sine omega t into a upon root a square plus b square plus cos omega t b upon root a square plus b square. Now what you can do, you are thinking now ki how to convert this into angles. It is not any angle. It is not the value of any angle of sine and cos, as we know. So what you will do, you will consider a triangle here. Okay, the base of which is B and the height or perpendicular is A. So the hypotenuse here will become A square plus B square. Okay, and this is theta. Now you can put sine theta and cos theta with in the place of this. Or for more specific value, what you will do, you will take this as phi. So now see the magic. X is equals to square root of A square plus B square sine omega t. You can write it as A over root A square plus B square, which is the value of sine phi, plus cos omega t cos phi b upon root A square plus B square. So it is cos phi. So this is the formula again. Sine A sine B plus cos A cos B. Or you can say cos A cos B plus sine A sine B. This is the formula of cos A minus B. X is equals to square root of A square plus B square into cos A minus B, which is omega t minus phi. Okay. So if you compare this equation number 1 with this standard equation A cos omega t plus phi, so you will find it out that amplitude here is nothing but square root of A square plus B square. This is the value of amplitude. Got it? In the same way, in the previous question, if you will see, if you are trying to find out, we have find it out the magnitude, amplitude as root 2, and this will become sine omega t plus pi by 4. So in this question also, the amplitude is the square root of square of coefficient written in front of sine and cos. Okay, so just note down what the coefficient written in the multiplication of sine omega t and cos omega t. Take the square root. Firstly square them, then add them, and then take the square root. Okay, that value is the final value of amplitude. Got it? And one thing also you can do here. Okay, chalo, we will do it in the next session. Now move to the next question. If x is equals to a sine omega t plus pi by 6 and capital X is equals to a cos omega t, then what is the phase difference between two waves? We need to tell the phase difference here. Very simple. Solution of this. Yes. Now here two waves is given to you, which is executing SHM because these equations belong to SHM. So these equations are of simple harmonic wave. So x is equals to small a sine omega t plus pi by 6 and capital X here is given to you as a cos omega t. Now definitely there would be a phase difference because it is cos here and it is sine. So what we are going to do, we will convert this. Either you can convert this cos function in sine, make both the function as sine, or make both the function as cos. So this is the simple thing that you can do. And this is the way of doing or dealing with these types of questions. So capital X, I think this would be the right one to convert. Okay. So this is a sine. If you convert cos into sine, you will write this expression as this pi by 2 minus omega t. Okay. Got it? Now, if you take sine pi by 2, sine 90 minus theta will become cos theta. Got it? So if you compare these equation, what is the phase difference now? You can also do the same thing here. It is written something like omega t plus pi by 6. So if you want to convert it into plus, what thing you can do? You can do that it is 3 pi by 2 plus omega t. Why? Because sine 3 pi by 2 will become cos pi by 2. It is 270 degree. And cos 270 plus theta, if it is going to in plus, so in that way it is going into the fourth quadrant. This is the first 90 degree, second is 180 degree, third is 270 degree, and fourth is 360 degree, 270 to 360. So this 3 pi by 2 is nothing but 270 plus omega t, which means we are in the fourth quadrant. And in fourth quadrant, cos will remain positive. So when this sign will convert into cos, that cos will remain as it is. No minus will add in this expression. So x here we can say that x is equals to a sine omega t plus 3 pi by 2. Now phase difference के लिए what we have to do? If this is the phase difference, how to find the phase difference? Just subtract the phase. Consider this one as phi 1 and consider this to be as phi 2. Now you will take this minus this or this minus this because phase difference is the mod of phi 1 minus phi 2. So we will take phi 2 minus phi 1 here. It will be omega t plus 3 pi by 2. So we will write it omega t plus 3 pi by 2. And this is omega t plus pi by 6. So minus omega t minus pi by 6. This omega t and omega t will cancel out. 3 pi by 2, which is 270 degree, minus pi by 6, which is 30 degree. So it will become 240 degree. If you want to convert it into pi, you just multiply it with pi by 180. So you can say 6/4 r and 6/3 are this. It will be 40, 30, 10, 10 cancel out. So this will become 4 pi by, the phase difference between them is 4 pi by, okay, got it? Now, I hope you got it. Move on to the next one. This question. So in this question, a simple harmonic oscillator has an amplitude capital A and time period capital T. Okay. Find the minimum time taken by it to travel from positive extreme plus A to a position root 3a by 2 from mean position. Let me again read the question. A simple harmonic oscillator has an amplitude capital A, which means the maximum displacement from mean position, and time period capital T. Now find the minimum time taken by it to travel from positive extreme plus A to a position root 3a by 2 from mean position. Okay. Now let me brief you with the situation. Let's say this is the straight line on which this simple harmonic oscillator is working. This is the mean position. Let's say x is equals to, nothing is given about the mean position where you have to take. So we will take it x is equals to 0. This positive extreme is plus a. This negative stream is minus a. Okay. Now read the question. Find the minimum time taken by it to travel from positive extreme, which means from here to a position root 3a by 2 from mean position. So this position we should measure from mean position. Let's say here root 3 by 2 into a. So if it is traveling in this direction, this much time it will take. Let's say is t. So we know that when the particle is at extreme position, the velocity of this particle will become 0. Okay. Now we know the equation in the displacement form because here only the displacement we are getting root 3a by 2 positive extreme. So instead of writing time equation, we should apply the equation of displacement. V square is equals to omega into, so V square is equals to omega square a square minus x square. Okay. This x is measured from mean position. Okay. Now here what the hack is that from mean position it is root 3a by 2. Root 3 by 2 into a. But it is not root 3 by 2a from mean position. Mean position it will be a minus root 3a by this much. Got it? Now this value you need to put into this equation. What will you get? Just a second. If you calculate the time from mean position to reaching out this position, let's say that time is t1. Okay. And the total time from 0 to capital A is capital T time period. If you subtract this time, only the time that you will get is this. Okay. That much is the time it will take reaching from root 3a by 2 to a or a to root 3 by 2a. Now, root 3 by 2 into a, just a second, x is equals to a sine omega t, we will consider it omega t plus 5. Okay. Now, for easiness, we will consider phi is 0. X is root 3a by 2 into a sine omega t. So a and a will also cancel out. So what do you have? You have sine omega t as root 3 by 2, which is pi by 6. Sorry, pi by 3. Sine 60. Sine pi by 3. If you take this, omega small t will become pi by 3. Okay. So time period it will take as pi by 3 into omega. So that is the value of this T1. This is equals to T1. You can put the value of omega is equals to 2 pi by capital T. This T1 will become pi by 3 into 2 pi by T. The reverse will be multiplied. Pi and pi will get cancelled out. So time it will take from mean position to reach root 3 by 2 is T by 6. Okay. Got it? Now, in T by 6, it is reaching root 3a by 2. From root 3a by 2 to reaching a, it will getting t minus t by 6 time, which is 5t by 6. Okay, so this value of time from this position to this is 5t by 6. Again, if it is moving from plus a to root 3a by 2, how much time it will take? The same amount of time it will take. And again, if it's reaching from root 3 by 2a to x is equals to 0, t by 6 time it will take. That is why the complete time it will take in this journey, just a second, it is t, na? Yeah, is t. And then again, it will take t coming back to this position. Now, this is t by 6 and this is 5t by 6. So, time taken by particle from reaching plus a to root 3 by 2 into a, okay, is 5t by 6. Okay, move on to the next one. This two particle oscillate simple harmonically with the same amplitude and same frequency along the same straight line. They cross each other when moving in opposite direction. Each time their displacement is 0.707 times of their amplitude when they are crossing. So what is the phase difference between them? So what we will do, firstly, do not hesitate with this 0.707, it is 1 by root 2. Okay. So when two particles oscillate simple harmonically with same amplitude, same frequency, which means omega and capital A is same for both. So if I consider the equation for one, it will be A sine omega t, let's see. And for another, it will be x2 is equals to A will be same, sine omega t plus phi. Some phase difference I have added. Okay. When they cross each other, when moving in opposite direction, each time their displacement is way by 1 by root 2 times of their amplitude. So we will compare it. A by root 2 if I put here at x1, A sine omega t. Okay. And this for this also it is A by root 2 equals to A into sine omega t plus phi. Okay. Now A and A will cancel out in this case also. In this case also. So it will become sine omega t is equals to sine pi by 4. So omega t has a value here, pi by. Here also, it is 1 by root 2. Sine omega t plus phi has a value of sine pi by 4. Sine omega t plus phi, which means omega t plus phi has a value of pi by 4 here. Omega t plus phi has a value of pi by 4. Now, if you put the omega t here, the value of omega t from this expression, it is pi by 4. Pi by 4. Pi by 4 and pi by 4 will cancel out. So phi that we have is 0 degree, which means there is no phase difference in these particles. Got it? Now, so this is the simpler one. Just compare the amplitude, get the value of omega t here also, and equate it to get the phase difference. This one. The maximum acceleration of an object in simple harmonic motion is 24 meter per second square. The maximum velocity is 16 meter per second and amplitude of the SHM. We know that A max will be when x is maximum. So it is minus omega square into, we have written the equation minus A. If I consider x to be A sine omega t plus phi. So the acceleration, or firstly we will write velocity. The velocity here will become A omega cos omega t plus phi, and acceleration here will become minus A omega square sine omega t plus phi. For the maximum value of V, for V max, we can say this cos omega t should be maximum because this is the only variable. So V max we have A omega. For this to be maximum, sine omega t must be 1. Okay. And the magnitude of it will be maximum as A omega square. If I talk about only the magnitude, not the direction. Okay. Now V max is given to you as 16 equals to A omega. And A max is given to you as what? 24 equals to A omega square. Now what you can do, you can put the value of A here. So A is 24 by omega square. 16 is equals to 24 by omega square into omega. Omega and omega will cancel one power of it. So omega that you have in your hand is 24 by 16. Just multiply it with this. So V max you have 16 is equals to 24 by 16 into A. So what is the value of A here? A will be 16 into 16 divided by 24. Now 8 to the 16, 8 3 is 24. So it will become 32 by 3 meter, let's see. Because velocity and acceleration all are given in meter. Amplitude here is 32 by 3. Same way you can do it for, if you put the value of A in term, if you put the value of omega in terms of A, then also you will get the same value. If you put omega is equals to 16 by A, so it will become 24 into A. Omega will become 16 into 16 divided by A square. The same A will cancel out. This 24 come in down the 16 by 16. Same value you are getting. So this is it. I hope you have enjoyed this session. This is it for today. Any kind of doubt you will have, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Take care of yourself. Do your study. Enjoy the day. Bye bye. Take care.